Welcome to PostgreSQL for MySQL DBAs. My name is Dave Stokes. I'm a technology evangelist for Percona. And we are going to be looking today at sequences. This is episode number 5 in the series. Why this series? Well, I've been a long time MySQL fan and I've used Postgres off and on over the past several years. But as I talk to MySQL DBAs who want to learn about about Postgres, they're kind of hesitant because it's just different enough to make you uncomfortable. So this is kind of a guided series to get you past the rough spots. So today we're talking about sequences, and this is much more than just auto-increment that you're used to with MySQL. What we're going to do is we're going to explain how sequences are roughly equivalent to MySQL's auto-increment. We're going to show you some cool tricks for sequences and then some more cool tricks. First, we need to find the equivalent to MySQL's auto-increment. And Postgres, as I mentioned, is different than the way MySQL does it. Not better or different, or better or worse, just different. So, Postgres has a serial data type. They have small serial and big serial, kind of like you're used to in MySQL with the small int, and big int. They respectively take 2, 4, or 8 bytes. And the ranges, as you see here, 1 to 32,000, 1 to 2 billion change, and 1 to 9, quadrillion. So depending on the size of the number of objects you're expecting in a table, plan accordingly. Now, MySQL also has a serial keyword, but it's not a data type. It's an alias for big int, not null, auto-increment, and unique. That can cause problems. If you specify unique and auto-increment / primary key, you can end up on 2 indexes, one for the unique and one for the primary key on the primary key column. And here's an example. Create table foo, ID serial. We do the show create table. You see that we do have unique key ID. And if we set up the same table roughly, but this time add primary key, we end up with 2 indexes on the primary key columns. One for the unique key and one for the primary key. That's extra overhead, extra storage, extra maintenance, extra IO, and you don't want that. So if you can, stick to unsigned, not null, auto-increment. Don't add in the unique. Now, here's a sample Postgres table with the serial data type. So first we're going to create a schema called test, which is simple enough to do. And then we're going to create a table called X, which is serial. A column X that's serial, a column Y that's a car 20, and a car Z that's also a 20. Now, as we look at the /D on this table, here's column X, integer, not null. And notice this function nextVal is going to go out and find a sequence on the column X in table X. Also, if we can create a schema called test. In 3, 2, 1. Hi, this is PostgreSQL for MySQL DBAs. My name is Dave Stokes. I'm a technology evangelist for Percona Corporation. And in this series, we're exploring Postgres. This episode is on sequences. Why this series? Well, I've been a long-time MySQL user, and I've used Postgres off and on in the past. As I talk to a lot of MySQL DBAs, they're curious about Postgres, but it's just different enough to cause problems when you're starting up. So this is a guided tour through setting up Postgres and the common pieces of the database server. Now, Postgres is different, not better or worse, different in a lot of areas. And one of those is sequences. And this is much more than what you're used to in the MySQL auto-increment world. So in this episode, we're going to explain how sequences are kind of equivalent to MySQL's auto-increment. Also, warning about auto-increment and unique keys. We're going to go through some cool sequence tricks that are really handy, and then some more sequence tricks. So, first thing we need to do is show you the equivalent to MySQL's auto-increment. Now, as I mentioned earlier, it's different, not better or worse, just a different approach. And in that, Postgres has a serial data type, small serial, serial, and big serial, like you're used to small int, and big int, taking 2, 4, and 8 bytes respectively. And as you can see over here, the data ranges, 1 to 32,000, 1 to 2 billion and change, and 1 to 9, quadrillion. So if you're setting up a table for a number of customers and you're expecting to have 2 billion customers or 9 quadrillion customers or 30,000 customers, set the size to the appropriate size. Now, MySQL also has a serial keyword, but it's an alias for big int, not null, auto-increment, and unique. Now, be careful when you specify unique and auto-increment / primary key. They're not mutually exclusive, but they probably should be. You can end up with 2 indexes on the unique and primary key column that you're going to want just to be the primary key. The example here is we're going to create a table ID foo, and when we do show create table foo, we see that we do have the index unique key on ID. This is how all the data is stored in the table. Now, if we specify serial primary key, we end up with the primary key, which is what we want, and then the duplicated unique key ID. So you have 2 indexes that have to be maintained, need I/O, all that, take up space in memory and disk. So you don't want that. So try to keep big int, whatever you want to use, unsigned, not null, auto-increment. Don't also specify serial. Now back to Postgres. We're going to create a schema called test. And we're going to connect to that schema with a \p. And we're going to create an example table. We're going to call the table X, the first column X, second column Y, and the third column Z. Now, if we do a /dx to display the table, kind of like a show create table, we see our 3 columns, their data types. But notice here that our primary column is not nullable, and it uses a function called nextVal that goes out to something called x_x_seq for sequence. So this is table X, column X, and the sequence that the system has set up for us. Now, if we insert into X some values, notice I'm specifying just the 2 character columns values here. It comes back and inputs that information, but you notice that the X column that we did not specify for table X is auto-incremented from 1 to 2. By the way, that insert is telling us the OID and the count. The count is the number of rows inserted, which you can see here we have 2 rows of data. And the OID is always going to be 0. That's a relic from past times, but an interesting fragment for some folks. Now, once again, you can see that X was automatically incremented for us. Now, the table and the sequence were created at the same time when we ran the create table. And if we do a /d on our test directory, we see that we have these schemas are in public view. We have the name of the relations. This is our table X, and this is the sequence on X column on table X. And of course, this tells us it's a table, it's a sequence, and the owner of the account that I used to create these. Now, if we go out there and we select star from that sequence, the last value is 2. And that's, I'm not going to cover on that for right now. So, basic sequences. Yes, you can create your own, and they don't need to be tied to a table. This is something much different than the auto-increment. If we want to create a sequence, we're going to call it order ID, and we're going to start at the value of 1001. If we select the next value of order ID, remember it's starting at 1001. There's our 1001. We want the next value. We get 1002. Now, if we check the data in that sequence, we can see that that is now set to 1002. Well, What if we want to just find the value without incrementing it? Well, you don't use next value, you use per value. So the current value for that we'd want for the next record going in would be 1003. Now, if you want to explicitly use next value in your insert statements, which I do recommend, it's as simple as you see here. Here we're putting in 4 columns of data: order ID, item ID, product name, and price. So order ID, the item IDs, which we're going to get the next value of the order item ID sequence, the name of the product, and the price. Now, don't confuse a series with a sequence. A series is like a sequence, but it's a bunch of numbers. It's not actually something that you're going to use to auto-increment with. So here we're creating a table called test1 as, and we're telling it to go out and generate a series with the numbers 1 to 100 as ID. So it goes out and selects our 100 records. And if we do a /d on test1, we see I have a column that's ID. We generate here, and it's an integer. And if we select the values from there, we get 1, 2, 3, 4, 5. Now, this was not automatically advanced by the server. The server created the series and put one record in at a time. So here's some more interesting stuff. Sequences can wrap. Here's an example where we're going to create a sequence called wrap sequence as an integer, minimum value of 2, max value of 2, and we're telling it to cycle. So we get our first value, it's a value of 1. Next value is 2, and because we told it to cycle, it goes back to 1 and 2 ad infinitum. Now, the syntax for creating a sequence is fairly simple. Create temporary or temp sequence and then give it a name. You can define the data type, the incremental value, min value, max value, where to start, whether it be cached, and who owns that if it's not specified. Now, MariaDB introduced sequences a while ago, and if you look at the difference in syntax between the two of them, there's not a whole lot of difference. They work very similarly. So if you've been using sequences with Maria, this won't feel so strange. By the way, if you type in /d sequence name, you can get details. Here's our order ID one we set up much earlier. We know it's a big int, starts at 1001, minimum, maximum, and the incremental value. It doesn't cycle, and by default it's cached. Now that wrap sequence where we've got one between 1 and 2, integer, start at 1, minimum 1, maximum 2, increments, and cycles. Now, on your server, if you type in /ds, you'll see the sequences in a particular schema. And to see all the sequences on the instance, you can go out and do select star from pg_sequences. Now, I'm going to do a quick little video to show you all these steps, and we'll cover everything that I just talked about. So let's get going. Let's create database test /c to connect to test. And we're going to create table X. X is serial. Y is *20. And Z is a *20. And if I do /d bits X, you see the information on our table. We have column X, which is integer, the other two are characters. Now notice here, X is not nullable, and the next value is going to be pulled from this sequence. Now, if we insert into X, specify the two character fields. Values 100, 200 for the first row. And for the second row, 300 and 600. Notice it comes back and tells us the number of rows inserted. This 0 is for the OID, something you don't have to worry about anymore. That's a legacy artifact. Now, if we do a /d x, whoops, the /d in this database, we'll see that we have the table X that we created up above, and then the sequence that was created when we created the table. And this is named for the table, the column, and then the name SEQ to let you know it's a sequence. Now, if we select everything from that sequence, x under SEQ, the information we get back tells us the last value, which is we did put in 2 rows, and the rest of this information, the 31 and the T, don't worry about that right now. So let's create just a sequence, not a table, just a sequence standalone. Create sequence. What E, and we're going to say it's going to start on the number 1001. And if we select the next value of the column, we get our 1001 where it started. Now that has incremented things, so if we do that next value again, it's now 1002. And if we go back and do select star order ID, we'll see that it will tell us that, yeah, we're now at count 1002. Now, if you want to look at that value without increment it, instead of using next value, per value, or per val. So something else to be careful of is the fact that Postgres has something called series. If you do that, that won't work. I'm sorry. Let's create a table. One as select generate series 1, m, it's ID, and select F1. That's the series that was generated. If we do a /e, F1, you'll see that this is not calling a sequence. It just generated those columns with those numbers there. That's handy for populating dummy data, but it doesn't actually set up a table that does like the auto incrementation. So let's create another sequence. We're going to call this one wrap sequence. And we're going to declare that as an integer with value 1, next value 2, and the keyword that here we want is cycle. SEQUE. We created our sequence. And if I type in its value It's going to start at our min value, which is 1. Select again, get 2. And here's where it cycles over. And we get 1, 2, 1, 2, 1, 2. And that is how that works. Now, if you wanted to take some information deeper on the sequences, if we go back to our order ID /d order ID, it tells us the data type, the number it started, the minimum value, and the maximum value, and how it increments. Now, if we do the same thing for sequence, you see that it starts at 1, minimum 1, maximum 2, and it does a cycle, which can be very handy. Now, if you're looking for information on all the sequences that are possibly in a schema, just type in df. You see there's the 2 we have created. Now, if you want to find the sequences on a server, from PG, and there's what we have. Well, thank you for watching this episode on sequences. Next time, we'll start looking at how to use explain to see what the optimizer wants to do with your queries. Thank you for watching.